Hi friends, in this episode we will see some important terminology or equipment starting in letter B. Before going to into the video, do not forget to subscribe, share it with your friends and colleagues, put your comment and like in comment box. You can see important terminology back pressure. The pressure and the outlet are downstream side of a flowing system. In an engine, the pressure which acts adversely against the piston causing loss of power. In other words, it is a resistance or force opposing the desired flow of fluid through pipes, leading to friction loss and pressure drop. Back pressure occurs when the downstream water pressure is greater than the water supply pressure. This can occur in any pressurized system such as chemical feed pumps, boilers, elevator tank, or recirculating systems. If the chemical feed pumps injecting into the water line, the water pressure is more means chemical cannot be injected. So the back pressure will be acting on the chemical pump discharge line. There is one type of example. In other words, if there is a restriction in the outlet strainer of the filter or any bed in the water treatment plant, pressure will increase and back pressure act from the discharge line, outlet line will act on the bed and it will restrict the flow. Next we will see about the balance drop. Normally it is used in solid firing, coal fire, crushed coal or pulverized coal boilers. A method of furnace air control using both forced and induced draft fans. The forced draft fan overcomes the resistance of the fuel bed, therefore sufficient air is supplied to the fuel bed for proper and complete combustion. Here you can see the schematic diagram of the balanced draft fan. It is a FD fan. It will supply air for complete combustion, proper combustion. This is economizer, this is a plant aerator. Here this is the ID fan, this is jack or chimney. This ID fan will create a vacuum or negative pressure in the furnace. If there is any choke in the plant aerator, you will get back pressure that will restrict the flow. Now we can see about one more important terminology starting from the boil up gas BOG. BOG means the gas produced due to vaporization of cryogenic liquid by heat conducted through the insulation. Usually evaporated LNG is called boil up gas or BOG. LNG is stored at cryogenic temperature around minus 162 degrees centigrade or minus 260 degrees Fahrenheit. Heat flow has an impact on evaporation process. It indicates there is continuous boil up small fraction or portion of LNG due to warming during storage process. LNG boil up gas flaring can be minimized by reliquefaction or recondensing of boil up gas using a small portion of LNG itself or by cooling with lean liquid nitrogen. This is one type of regasification or reliquefaction, recondensing or reliquefaction of process of BOG is an LNG storage tank normally due to the insulation failure or any heat the evaporation will be there, so we cannot fill up to the brim. Normally some space will be given left out to accommodate the vapors. The boil of gas produced is collected and compressed and sent to the heat exchanger. This is a reliquefaction like the LNG pump itself. One portion is coming and going through the heat exchanger and the boil of gas coming inside get cooled and it's back to the tank. And there's a similar process to LNG vaporizer for the natural gas regasification. By means of this type of reliquefaction or recondenser process using the heat exchanger in the LNG itself, you can minimize the flaring. You can see another type in the next slide and another reasons are important reason for boil up gas, how it is produced, why it is produced. In the previous slide we have seen about the boil up gas and boil up gas liquefaction. Now we can see the reasons for boil up gas generation. There are several sources responsible for boil up gas generation. The first one is heat ingress source due to the insulation failure or some gap in insulation. Second one is cooling down of tanks when cooling down is done in the offshore or any unit using the LNG that pile of gas will produce. Third one is LNG loading and unloading condition. During that time, loading and unloading normally a pile of gas will be produced. Fourth one is the cargo tank pressure. Cargo tank pressure itself will have some impact on the BOG production. The last one is sloshing of cargo. Normally it is when the cargo or FSC floating storage unit or the ship is having the storage in the sea, in the offshore. The energy transmitted from the sea waves act from the outside. The energies that influence the movement of liquids inside of the tanks, both the liquid motion and its effects are called sloshing. An equipment called anti-slosh baffles normally provided to absorb the kinetic energy of the waves. Should have is a gasket-like arrangement. This produced are provided inside the tank to avoid the sloshing. Due to the wave movement and the more liquid motion inside the tank or cargo, the sloshing effect will be happening. So these are the 5 reasons why BOG is produced in the offshore or any other area where LNG is stored. In LPG storage also, boil of gas will be produced during storage and also during transportation. Normally in offshore, you have to minimize the flaring or any gas to minimize the boil of gas flaring. Boil of gas reliquefaction or recondensing. LNG boil of gas flaring minimize is called reliquefaction or recondensing of biology using a small portion of LNG itself or by cooling with lean. In the previous slide, we have seen the BOG recondensing using the LNG itself. Now we can see the recondensing or reliquefaction using the liquid nitrogen. On the boil of gas compressor, the gaseous natural gas compressed is coming into the purification unit. This is a schematic diagram of this recondensing. The gaseous nitrogen is gaseous natural gas is coming inside the purification unit, and this is the liquid nitrogen storage which is having liquid nitrogen at minus 196 degrees centigrade. Here the liquid natural gas storage minus 162 degrees centigrade. This natural gas BOG from the compressor discharge is coming into the purification unit, getting cooled. Here the liquid nitrogen is going into the heat exchanger. Here the boil of gas coming from the compressor will get cooled and condensed and is going to the storage. So BOG flaring is minimized. The liquid nitrogen after getting some heat further cooling the incoming natural gas and going as a gaseous nitrogen outside to vent. And this process is called liquefaction or recondensing of natural gas. Normally, all offshore it will be they'll be having this type of liquefaction process. Normally, in offshore, using the LNG itself, recondensing will be done. In other plant, we can use liquid nitrogen storage for cooling the or recondensing the LNG BOG gas produced. Hope you might have understand some important terminology I keep on starting from B. Put your comment and like in the comment box. Do not forget to subscribe. Share it with your friends and colleagues. We'll see with some more important terminology or equipment sorting in B in the next episode. Thank you very much.